methods of preparation, okay, the reactions. So today we are just doing the chemical properties of your haloalkane. We will start that. So let's wait for others, then we will start the session. Ali, is this chapter included in your half-yearly exam?
Ma'am, my half-yearly exam is finished.
Yes. Can you please repeat?
Ma'am, my half-yearly exam is finished.
Okay, it's finished already?
Yes, ma'am.
Okay, okay. Okay, no issue. How's your exam, Ali?
It was easy. I got some marks.
Okay, let me check will other students will join or not, then we will start the session. Okay, Ali, so let's start the session. I think they will not join the session because they are not well. All the three are not well. So let's start. Okay, Ali, are you ready? Okay, so chemical properties of haloalkenes. So chemical properties of haloalkenes. So there are three chemical reactions of haloalkenes. First one is your nucleophilic substitution reaction. Second is your elimination reaction. And the third is your reaction with metal. So one by one, we will understand these three reactions of haloalkenes. Okay. So first one is your nucleophilic substitution reaction. Now let's understand the meaning of this word nucleophilic. So what does nucleophilic means? Nucleus, nucleo means nucleus. It comes from the word nucleus. Okay, and you know very well nucleus is positive, right? Because it has a proton. So nucleus क्या होते हैं? Positive होते हैं. And the phile. What does phile means? The loving. Okay, philic means loving. So they are nucleus loving. Okay, so they are nucleophilic substitution reaction are those reaction in which the group of substrate. So see, first understand the word what is substrate and nucleophile. So substrate is basically a organic reactant molecule. Organic reactant molecule. Because we are just doing the nucleophilic substitution reaction of haloalkene. So here the substrate is your haloalkane. RX alkyl halide, or you can say haloalkane is the substrate over here. And what is nucleophile? So nucleo means nucleus, okay, positive, and phile means loving. So nucleus loving, they are known as nucleophile. Okay, and they are electron rich because you know nucleophile कौन होंगे? जो जिनके पास electrons होंगे. Okay, that group or that molecule which has a electron, which is electron rich. So that's how. So if they have electron rich, they will try to attract the positively charged body, right? Means nucleus. So they will love nucleus. So nucleophile. That's why they are nucleophile. Nucleus loving. So nucleophile basically they are इलेक्ट्रॉन रिच सो दैट्स व्हाई इस पे हम क्या माइनस सिंबल से शो करते हैं दिस इज NU इज फॉर द न्यूक्लियोफाइल एंड माइनस बिकॉज दे आर इलेक्ट्रॉन रिच okay because they have a minus charge over it so they will attract positive charge okay positive charge कौन से होते हैं your nucleus okay the positive charge is your basically suppose we have a RX your RX right so this is alkyl halide. This is a substrate over here. In this reaction, there are two types of components. First one is a substrate and the second is your nucleophile. Okay, so what happens? You know very well this is RX bond. Okay, so R alkyl group के पास क्या है? This is a carbon. Alkyl group contains carbon. And because X halogen group is most electronegative, so they will acquire partial negative charge. And R group, alkyl group, carbon of the alkyl group basically, it will acquire partial positive charge. So here, when the nucleophile come, so nucleophile किसको attack करेगा? R group or X group? Yes, Ali. So nucleophile will attack which group? R or X? Yes, you are not audible, Ali.
It will attack the R group.
Yes, it will attack the R group because it has a partial positive charge. Okay, and this is a nucleus loving, so it will goes to the positive charge. Okay, so that's the nature of the RX bond and the nucleophile. So what is nucleophilic substitution reaction? So substitution is basically a replacement. Okay, you will replace one group with another group. So here, nucleophilic substitution reaction is the reaction in which a group of substrate is replaced by a nucleophile. Okay, so they are nucleophilic substitution reaction. See the basic general reaction is this is your RX, this is a substrate over here. What is this? This is a substrate, alkyl halide, and this is a nucleophile. So when nucleo substrate को आप react कराओगे nucleophile के साथ, suppose we have NaOH, sodium hydroxide. Okay, if you treat this haloalkane is treated in the basic medium. Okay, if you put the haloalkane in the basic medium, if you treat it with the sodium hydroxide, so what happens? The sodium will dissociate, the sodium hydroxide will dissociate to form Na plus and OH minus. Now nucleophile क्या होगा इसमें से Na plus or OH minus? So OH minus is a nucleophile because it has a negative charge, right? So this nucleophile will come and replace, because see what will be the mechanism over here? This will acquire partial negative charge and this R will acquire partial positive charge. So this nucleophile is negatively charged. So this will come and attack this R group. Okay. So when once it attack the R group, carbon of the alkyl group, the halogen, is a good living group. They are a good living group. So they just leave the molecule. यहाँ से ये bond break हो जाएगा and you will get R nucleophile. This R NU bond will be formed. This will be the new bond, and hex X here, which is a halogen group, which will be removed from the reaction. So that's the whole mechanism of the nucleophilic substitution reaction. When the nucleophile attack the R group, okay, carbon of the R group, so from here the uh, living group will leave the molecule and you will get the new product. Okay, you will get the product. So in nucleophilic substitution reaction, one base, so one group or base, you can say one base is replaced by another base. So the incoming base is, so this is your incoming molecule. So this incoming molecule or incoming base आप कह सकते हो, incoming group कह सकते हो. So this incoming group is called the nucleophile, and the outgoing, this is the outgoing group. ये left कर रहा है group. Okay, bond को. So this outgoing base or outgoing group is known as living group. Got my point, Ali? Okay. So here, suppose this is a question. Identify the nucleophile and the living group in the following. Okay. So first, if I say, first is your, so this is a nucleophile. So CN minus. So see, Ali, so cyanide जो होते हैं, it's a ambidentate nucleophile. Now the question is, what is ambidentate nucleophile? Do you know what is ambidentate nucleophile, Ali?
They can attack from uh,
Yeah.
both the sides.
Yes. Basically, that nucleophile which has more than one attacking site, okay, one more than one donor site is known as ambidentate nucleophile. So cyanide ion is a ambidentate nucleophile. In some molecule, it will attack from the carbon side, and in some molecule, it will attack from the nitrogen side, right? So this is a CN minus. So here, what happens when you treat this? This is your substrate. This is a substrate, and this is a nucleophile. Okay, so you have to, first you have to write down the reaction, and after that you have to tell me which one is your nucleophile and which one is your living group over here. Okay, so what will happen over here? So here this bromine when cyanide kiske attack karega? This is a R group, this is a carbon, right? So when this bromine, which is electronegative, so this will acquire partial negative charge. Okay, and bromine se kya attached? This carbon, so this carbon will acquire partial positive charge. And now this cyanide, CN minus ion, so it is an ambidentate nucleophile. So here, basically, it will attack from the carbon side. You have to remember this will attack here from the carbon side. So this will come and attack over here. Okay, basically, so cyanide will come and attack because this is a nucleophile. It has a negative charge over it. So it will come and attack here on this carbon, which has a positive sign. So now what will be the, so when this nucleophile will attack this carbon, so at the same time, simultaneously, this bromine will left because it's a good living group. So यहाँ से ये left कर देगा and you will get this product. CN plus Br minus. Okay, so what is nucleophile over here? So nucleophile here is cyanide minus, so cyanide ion, and your living group in this is Br minus. Okay, bromine minus. This ion is a living. Okay, do the rest of the question, Ali. Second, third, fourth, fifth, and sixth. Okay, just quickly do that and I will ask you the question. Once it's done, please update me. And this NO2 group is again a amide internucleophile. Second one done. E. Yes, tell me what will be the product over here?
I'll with NO2 and Cl minus.
Okay, very good. And the product will be here. The chlorine will be replaced by your NO2 group. NO2 group over here, this will be your product, plus this will left the group. So here the nucleophile is NO2, NO2 minus, nitroine, and the leaving group is chlorine ion. Third one, so similarly you can do that. Okay, what you're supposed to do here, this is a nucleophile H minus. It is a nucleophile, so it will attack over here this carbon, because this carbon will have the partial positive charge and this bromine will have the negative charge. So when this nucleophile will attack this carbon, so it will left the group and you will get this. Okay, here the hydrogen will be attached. So plus your bromine minus. Okay, so similarly you can write down the nucleophile and the leaving group. Okay, fourth one, CH3O minus. Okay, so it's very simple. Here the nucleophile is given. So what you are supposed to do, just attack the nucleophile, okay, here on this carbon and it will left the group. So you will get this product. This is your benzene and this is the CH2 group and here CH3O, OCH3. CH2 and here OCH3 will be attached. Next one, yeah. Now tell me in the fifth question, what is the nucleophile?
OH negative.
Yes, OH minus is the nucleophile. So it will attack here, this carbon, and this chlorine will left the group, and you will get this OH over here, plus your Cl minus. Yeah, in this one, H2O, okay, what is the nucleophile?
OH minus.
Yes, again, because this water will dissociate to form H plus and OH minus. Okay, so OH minus is the nucleophile.
Yes.
Hence, OH plus Cl minus. Similarly, you can do the same thing over here in these two questions. Now, okay. So what you're supposed to do basically, RX bond will be break. This bond you have to break. Okay, haloalkene का जो bond है, this bond RX bond will be break, and new bond will be formed between the nucleophile and the alkyl group of the haloalkene. That's what you have to do. You have to do in the nucleophilic substitution reaction. Now, let's understand the types because this type is very, very important. So when R and RX bond breaks and the R nucleophilic, this RNU bond will form. Okay, so on the basis of these two, bond formation and the bond breaking or the cleavage of bond, आप कह सकते हैं. So the cleavage of bond and the formation of bond, okay, on the basis of these two, there are two types of reaction, two types of nucleophilic substitution reaction. First one is your single step reaction. If these both these means the cleavage of RX bond and the formation of RNU bond. Okay, so both, if these two steps occurs in the same step, in a single step, then this type of reaction is known as SN2 reaction. Okay, so just remember, single step में हो रहा है तो it's SN2, not SN1. Okay, so just opposite आपको याद रखना है. If this both the steps occurs in the single step, means the breaking of bond and the formation of new bond with the nucleophile. Okay, so both takes place in the single step, so it's known as SN2 reaction. SN2. Now, what does this mean? N S आप capital लिखते हो, and again the capital, and you will write here in the subscript of the S, and this 2, just like this, you will write down the nucleophilic substitution. So what is N? N is the nucleophilic, S is the substitution, and what is 2, which is on the superscript? So it shows the molecularity of the reaction. So SN2 means it's a bimolecular. It's a bimolecular type of reaction. आपने ये पढ़ा होगा chemical kinetics में, molecularity and the order of reaction. Have you completed the chemical kinetics, Ali?
Yes, ma'am.
Yeah. So in that chapter, you have already done that. What is the difference between order and molecularity? So this 2 basically, it shows the molecularity. That it shows that this nucleophilic substitution reaction is bimolecular. It depends on 2 molecules. Means your ये nucleophile पे भी depend करेगा, and it will also depends on the substrate. So here you can see this is the reaction. Means the cleavage of Rx bond, this Rx bond will cleave, okay, and the attack of nucleophile will occur in the same step, in a single step. So it is known as nucleophilic bimolecular nucleophilic substitution. So say this is the nucleophile. So this is the Rx bond. So again, this will acquire partial negative charge, and this R will acquire partial positive charge. So when nucleophile will come, it will attack this R group. Okay, so here this bond will be break. The bond cleave हुआ bond, and this X group, because it's a good living group, so it just left the molecule, and here the new bond will be formed between the R and nucleophile. So here you can see the breaking of the Rx bond, cleavage of the Rx bond, and the bond formation, new bond formation, RNU. This bond formation occurs in a single step. So this type of reaction is known as bimolecular nucleophilic substitution reaction. Okay, and if you have to write on the rate of reaction, so rate किस पे depend करता है? So rate is directly proportional to the concentration of your reactants. So here the reactants are nucleophile as well as the substrate. So the rate will be directly proportional to the nucleophile as well as the Rx. Okay, so that's why it is bimolecular. So in bimolecular nucleophilic substitution reaction, rate is directly proportional to the nucleophile. It depends on the nucleophile concentration. Plus, it also depends on your substrate concentration. Substrate means your haloalkene. Okay, दोनों के ही concentration पे depends करता है, right? So that's why it is a bimolecular nucleophilic substitution reaction, and it occurs in a single step. Got my point, Ali?
Yes, ma'am.
Second. So second type is 2-step reaction. When this both, like first step में होगा, there will be a bond break. Bond will be break. This Rx bond will be break, and in the second step, the bond will be formed. New bond will be formed between the R and nucleophile. So when these 2 steps occurs individually, means when the reaction, whole nucleophilic substitution reaction occurs in 2 steps. So it is known as your mononucleophilic substitution reaction. Okay, so it's a monomolecular. Okay, आप बोल सकते हो one होता है, इसका molecularity will be 1 and SN1. That's why it is written as SN1 type. So bimolecular reaction, and this is your unimolecular. Okay, monomolecular भी कह सकते हो, unimolecular means the molecularity is 1. So this is your unimolecular nucleophilic substitution reaction, which occurs in the 2 step. Now let's see what will be the first step. So first step will be the cleavage of this bond. This Rx bond will be cleaved, okay? And when it cleaves, so you know very well, this is X halogen is your most electronegative, so it will acquire partial negative charge. So X के ऊपर क्या आएगा negative charge, but this R will have a positive charge. And what is this? If carbon के ऊपर positive charge आता है, तो it is carbocation. It's a carbocation because alkyl group contains carbon, and if the positive charge occurs on the carbon, so it is your carbocation. So first step in the unimolecular nucleophilic substitution reaction is the formation of carbocation. First step will be the formation of carbocation. Now see, if carbocation is formed, okay, so what happens in the second step, the nucleophile will come and attack this carbocation and it will form the new bond, which is RNU. So this is the two-step mechanism. First step में क्या होगा? The formation of carbocation, and the second step includes the attack of nucleophile. So this type of reaction or mechanism is known as unimolecular nucleophilic substitution reaction, and it occurs in two steps. And here the rate, because you can see the rate depends. So this is a two-step mechanism. So आपने chemical kinetics में पढ़ा होगा. So for this rate determining step is the slowest step, right? So first step is very slow. In these two steps, the formation of carbocation, this first step is very slow. So the rate determining step is the slowest step. Rate determining step क्या होता है? The slowest step. So the slowest step, so basically here you can see in the slowest step, the reactant is only haloid, not the nucleophile. So in this unimolecular nucleophilic substitution reaction, so the rate will only depend on the concentration of your haloalkene or substrate आप कह सकते. So here the rate is directly proportional to the concentration of Rx because rate determines on the slowest step, and this is the slowest step, the formation of carbocation. So that's why in the unimolecular nucleophilic substitution, the rate does not depend on the nucleophile. Okay, rate only depends on the Rx, means the concentration of halol. Clear, Ali? Okay. So now you can write this. So types of SN reaction, SN1 and SN2. SN1, it refers to the unimolecular nucleophilic substitution reaction, and the reaction in which the rate depends on the concentration of substrate only. So is known as nucleophilic substitution reaction, unimolecular nucleophilic substitution reaction. Okay, so here the rate is directly proportional to the concentration of Rx, and the rate when you remove this proportionality sign, so here will be the rate constant. So order of this SN1 reaction is 1 and molecularity is again 1. So that's SN1 reaction. Okay, the main thing is the mechanism. The mechanism is very, very important. Okay, so just concentrate here. Now, so because as I told you, it's a two-step mechanism. It follows a two-step mechanism. First step में क्या होगा? The formation of carbocation. The breaking of CX bond. Here you can see the breaking of CX bond. Okay, means RX bond. So alkyl group has a carbon, so that's why I have written CX bond. So the breaking of CX bond or the formation of carbocation. So when this bond will break, okay, so this is the slowest steps. So here the carbocation will be formed. Suppose we have 1, 2, 3. Okay, 1, 2, 3 groups. Like 1, 2, 3 same group bhi ho sakta hai, and it could be different also. Okay, so here the carbocation will be formed. When you remove this, when this living group left the group, so here the formation of carbocation. And this is the slowest step. This is a rate determining step. Second step, once the carbocation is formed, so see the position of the group 1, 2, and 3. Okay, so why I have written 1, 2, and 3, three different groups over here to make you understand something over here. So first step clear, the formation of carbocation. Second step was the attack of nucleophile. Now here you can see this is the carbocation, carbon. This is a plus charge over here, and there are 3 groups over here. Okay, now there are two ways by which the nucleophile can attack this carbon. Nucleophile is negatively charged. This is electron rich. ये किसके पास जाएगा? Which has a lack of electron. Okay, means a positive charge. So nucleophile will come, and there are two ways by which the nucleophile will attack this carbon. Either from the front side, okay, which I have represented by this red color, okay, or by the back side. So in both the things, in both different ways, you will get different compounds. The orientation of the molecule will be different. The orientation will be different. Now see if this nucleophile will attack from the front side. This red color is the front side. तो आपका क्या बनेगा? Front side से attack होगा तो okay, let's see. So when it attacks from the front side, so this is your carbon. Okay, so this front side से करेगा nucleophile attack, so you will get this OH over here, OH, and this is your 1, 2, and 3. 1, 2, and 3. Now, second one. This is the molecule. This is the product when the nucleophile will attack. और आप यहाँ पे nucleophile show कर सकते because I have not written what is nucleophile over here. So here they and you. Okay, and you. Now see when this nucleophile will attack from the back side, back attack hoga, then you will get this product. This is the nucleophile. You have to show it over here. Okay, this is the first, this is the second, this is the third. Okay, now let's compare these two products. So first product, when the attack is from the back side से attack होता है, तो you will get the inversion product. Now see, what was the original molecule? What was the reactant? Substrate क्या था आपका this? Okay, now compare the substrate orientation with this product. Which one is same? First one. Okay, this one. When the nucleophile attacks from the front side, when the nucleophile attacks from the front side, so the orientation of the molecule, orientation of the groups in the molecule will be same. So this product is known as retention product. Retention product. Retention क्या होता है? Retention means when the orientation is over here is same. Okay, orientation retained कर गया. But here you can see the nucleophile attack from the back side. When it attacks from the back side, you will get a inversion product. Here, what happens? The orientation of the molecule will inverse. Inversion means inverse. It comes from the word inverse. So here, you will get inversion product. So in the nucleophilic SN1 reaction, okay, unimolecular nucleophilic substitution reaction, you will get a racemic mixture. You will get a racemic mixture. 50% आपको मिलेगा your retention product, and 50% you will get a inversion product. 50% is the inversion product and 50% is the retention product. Yeah, and what is the retention product? Means the orientation. Retention क्या होगा जब orientation of the product will be same as that of the substrate reactant. Okay, so this was a substrate. Substrates you can check 1, 2, 3, and on the right side there's a nucleophile. So yeah, it's same. So this is the retention product. So you will get 50% retention product, and see this is the inversion product. Inversion product कब मिलेगा? When the attack is from the back side. When the attack is from the backside, and you will get an inversion product, and when the attack of nucleophile is from the front side, you will get a retention product. And the mixture of this 50-50 mixture, like retention 50% you will get and 50% inversion product you will get. So this mixture is known as racemic mixture. Racemic mixture. Got my point, Ali? Okay. So this is a racemic mixture. So you have to remember this point. Front side से attack होगा nucleophile का, so you will get a retention product. And when the attack of the nucleophile is from the back side, so you will get a inversion product. Means the inverse, the orientation will be inverse. Okay, so that's the mechanism. That's the mechanism of the SN1 reaction occurs in the two steps. First step, formation of carbocation, okay, or the breaking of CX. Second step, once the carbocation is formed, the nucleophile can attack either from the front side or from the back side. When the nucleophile attacks from the front side, you will get the retention product, 50% retention product. And when the nucleophile attacks from the back side, you will get a 50% inversion product. Okay, and the mixture of these two mixture with 50% of mixture milega, this is known as racemic mixture. Racemic mixture. Okay, now see this point. So SN1 reaction occurs via intermediate carbocation. Okay, so you can see over here, SN1 कैसे बनता है? It forms via intermediate carbocation formation. So here, the rate of SN1 unimolecular nucleophilic substitution reaction is directly proportional to the stability of carbocation. Okay, and just remember, 3-degree carbocation is most stable as compared to 2-degree and 1-degree. So that's why the rate of SN1 reaction, the order of rate of SN1 reaction is first 3-degree में सबसे fast होगा, after that 2-degree and then 1-degree. So that's the rate of SN1 reaction. And just opposite किसमें होता है? SN2 में. SN2 में the primary, then secondary, then tertiary. Got my point, Ali?
Ma'am.
Okay, so SN1 gives, yeah, see this point, as I just discussed it, 50% inversion product, 50% retention product. And the mixture with 50% inversion, what is I over here? It's inversion, and 50% retention is called the racemic mixture. And this process, and this whole process, the formation of the racemic mixture is known as racemization. Is known as racemization, in which you will get the racemic mixture. So that's all about the SN1 reaction, unimolecular nucleophilic substitution reaction. Okay, now the second is nucleophilic substitution reaction bimolecular. Bimolecular nucleophilic substitution reaction. Okay, so SN2 reaction क्या होता है? It refers to the bimolecular nucleophilic substitution. Yeah, and the reaction in which the rate depends on both, okay, on both haloalkane and nucleophile. Haloalkane means the substrate पे भी depend करता है and also on the nucleophile. So that's the SN2 mechanism, SN2 reaction. And again, as I told you, 2 क्या show करता है? 2 is the molecularity. So if the molecularity over is 2, order will be also. So in SN2 reaction, the rate depends on both substrate as well as the nucleophile. And the order is 2 and the molecularity is 2. Now, let's understand the mechanism. Because it occurs in a single step. So here, it will form 100% inversion product. So here, nucleophile has no options. Okay, it will attack from the front side only, not from the back side. So if it attacks from the front side, you will get a 100% inversion product. So SN2 type में कुछ ऐसा नहीं होता, like you will get 50% inversion or 50% retention product. So in this, you will get 100% inversion. Okay, now let's see how you will get 100% inversion product by the mechanism. So mechanism is, as you know, it's SN2 है, तो SN2 means single step. Okay, so just opposite, it's 2. So 2 doesn't mean that it's a step. A step नहीं show करता. 2 is the basically molecularity. 2 is for the molecularity or order. So single step होते हैं, and here the breaking of CX bond and the formation of this carbon and nucleophile, this new bond takes place simultaneously. Now let's see how it occurs. So what happens over here? So this is a CX bond. CX bond. And you know what is the nature of CX bond? X is electronegative. So in this CX bond, this will acquire partial negative charge and this will acquire partial positive charge. And what do I mean by electronegativity? So electronegativity is basically a tendency to pull the electrons, pull the electron density towards itself. So this is the electronegative element. X क्या है? Halogen is the most electronegative element. तो ये क्या करेगा? It will try to pull the electron density towards itself. Okay, when it pull the electron density towards itself, so it will leave the group. It will leave the group, and यहाँ पे क्या होगा? Electron density कम हो जाएगा carbon के पास. So once the electron density will reduce to this carbon, so it will acquire partial positive charge. Once a partial positive charge ये acquire कर लिया, then the nucleophile will come and attack this carbon, because nucleophile क्या है? It's a electron rich, and it will go and attack to the electron deficient species or deficient carbon, right? So nucleophile will come and attack this carbon, and this X will remove from this. Now see, this is a transition state. So transition state you can show like this. So this is a carbon, 1, 2, 3, different groups. Here the nucleophile. So this is the old bond. Sorry, this was the old bond which I have shown it from here, red color. Carbon and X, halogen bond. This is the old bond, and this is a new bond which has to be formed. Carbon and nucleophile bond, right? So what happens? This is quite unstable. Transition stage जो होता है, this is very unstable. This is very unstable molecule. So this old bond will be break, and the new bond will be formed. New bond will be formed, and the old bond will be break. So what happens when this bond will break? So X minus, okay, it will remove as a X minus because it's a good living group. And now this new bond will be formed, carbon and nucleophile के बीच में. So you will get this. And you can check the orientation is just same. Okay, orientation is reverse. Okay, inversion product हो रहा है, right? So inversion product, so here the always backside attack होगा, not from the front side. Okay, मैंने mistake से बोल दिया. So 100% inversion product. So inverse कब होता है? Inverse orientation कब होता है? When the attack is from the backside. So here backside attack. Backside से attack होगा, and you will get the 100% inversion product. So you can check when you compare these two orientation. This is a reactant, you substrate. So you can see 1, 2, 3. This is on the left side of this carbon, and the halogen is on the right side. But here the orientation just got reversed. Carbon and these three groups are on the right side, but the nucleophile is on the left side. Means the orientation has been reversed. Okay, inverse हो गया your orientation of the molecule. So that's why you will get 100% inversion product. And why it has been inverse? Because the nucleophile here attacks from the back side. So यहाँ पे क्या हो रहा है? Back side attack हो रहा है of nucleophile. Back side attack. That's how you will get the 100% inversion. Got my point, Ali?
Yes, ma'am.
Okay, next question. Here's a question. CH3Br. So what is this? This is a substrate. Alkyl halide. Okay, and NaOH, sodium hydroxide. So from here, OH minus is the nucleophile. So, and your product is basically, there will be a replacement of OH. The OH क्या होगा? OH will substitute in the place of bromine, and bromine is a good living group, so it's just like the molecule. And you will get CH3OH, methanol plus sodium bromide. Now the question is how you will write down the mechanism. I will show the mechanism of this reaction. So this is a CH3Br. C, 3H, 3 hydrogen, and bromine over here. Okay, again, the same thing. Again, it's a SN2 reaction. Okay, SN2 mechanism. It's an example आप लिख सकते हो. It's an example of SN2 reaction. Now what happens when the nucleophile, what is nucleophile over here? OH minus. So between this carbon and bromine, because bromine is electronegative, so it will just pull all the electron density towards itself. उसकी वजह से क्या होगा? It will acquire partial negative charge, and this carbon will acquire partial positive charge. Okay, now this, when electrophile will come, sorry, nucleophile, not electrophile. Nucleophile will come, it will attack the positive carbon. Okay, so once it attack the positive carbon, so Here the transition state will be formed. Okay, was the old bond, carbon and bromine as the old bond, and that's the new bond. So this is quite unstable. So old bond you have to break and the new bond will be formed. And you can see the orientation is quite reverse. So it's a 100% inversion product plus Br minus you will. Br minus. Basically NaOH hai, so you will get NaBr. You will get NaBr over here, sodium bromide. So that's the whole mechanism of the reaction and it occurs via SN2 mechanism, means single step mechanism. Clear, Ali?
Yes, ma'am.
So in SN2, the attack of nucleophile is from the behind, which is from the back side. Okay, 100%, you will get a 100% inversion product. Okay, one more point, it's very important. The rate of bimolecular nucleophilic substitution reaction is inversely proportional to the bulky group on alpha carbon. Bulky group on alpha carbon. If on alpha carbon, if there is more bulky group like C2H5, CH3, and like pentyl group, any group which is very bulky, so it will reduce the rate of nucleophilic substitution reaction. Okay, and we are talking about the alpha carbon. So suppose we have these two examples. Example is two molecule हमारे पास. Okay, two compounds you can say. C bromine. Bromine is attached to this carbon. So what is alpha carbon? So this functional group is attached to this carbon. So this is your alpha carbon. This is your alpha carbon, and these are beta 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 carbon. Similarly, the second molecule, this is the alpha carbon. Now, when you compare these two, you can see the here on the alpha carbon there are three bulky groups present. In the first A molecule, in the A compound, there are three bulky groups attached on this alpha carbon. C2H5, ethyl, methyl, and your pentyl group. You can see bulky group hai yahan pe. And here in the second compound, you can see only hydrogen is present. Only hydrogen is present means there is no bulky group on the alpha carbon. So more the bulky group on the alpha carbon, less will be the rate of nucleophilic substitution reaction because it has the inverse relationship with the rate of nucleophilic substitution reaction. So between A and B, Ali, tell me which one will have the more fast rate of reaction. Rate of reaction किसकी ज़्यादा होगी, A or B?
B.
Yes, very good. It's B. Why it's B? Because here on the B, in B, the alpha carbon will, there is no bulky group on the alpha carbon, but in the A molecule, there are three bulky group present on the alpha carbon. And you know very well, the bulky group reduces the rate of nucleophilic substitution reaction. So that's why B is more reactive towards the nucleophilic substitution reaction. More reactive कह सकते हो आप ये, or you can say the rate of reaction will be fast in B as compared to. Okay. So SN2 occurs via transition state. SN2, SN1 क्या था? SN1 occurs via intermediate carbocation formation. But here SN2 mechanism occurs via transition state. Okay, so in SN2, we get 100% inversion product due to backside attack of nucleophile. Okay, so there are some examples of SN2 reaction you can write. So this is a CH3Br, okay, your alkyl bromide, methyl bromide. So when first methyl bromide is treated with KCN, potassium cyanide. So potassium cyanide, so say in potassium cyanide, when it attacks, potassium cyanide is very ionic type. It will break as K plus and Cn plus. So just remember that we will discuss in details when we do the ambient nucleophile. Okay, and we will see various reactions and why the attack will be from the carbon side or the nitrogen side. We will understand each and everything. But here you have to just remember when the KCN, potassium के side अगर cyanide है, if the cyanide group is with the potassium element, So here the attack is from the carbon. The donor site will be the carbon. Attack किस side से होगा? Carbon side से, not from the nitrogen side. Okay, but when it attached the cyanide, same cyanide group, when it is attached to the silver, when it is attached to the silver, then in this case the attack of nucleophile or donor site क्या होगा? Nitrogen, not the carbon one. So these two differences you have to remember. Potassium के साथ कभी भी cyanide group है. So the attack will be from the carbon, not from the nitrogen. And when the reagent is with AgCN, Ag silver cyanide. So the attack, it will always form the isocyanide, not the cyanide. Okay, means the attack will be from the nitrogen. Donor side क्या होगा? Nitrogen, or not the carbon in this case. Got the point, Ali?
Yes, ma'am.
So here you can see when you react CH3Br. So here what is nucleophile over here? Cn minus. Cn minus, and it will attack from the carbon side and you will get CH3Cn, which is methyl cyanide plus KBr. Similarly, in the second case, AgCN, as I told you, here when silver ke saath hai, the attack will always from the nitrogen side. Okay, so here it will form isocyanide, and आपको कैसे show करना? NC. You will show like this CH3, and the donor side is nitrogen, so that's why you have to attach the nitrogen to the carbon. CH3NC. So this is a methyl isocyanide. So it will always form isocyanide when the AgCN is present. The attack will be from the nitrogen and you will get isocyanide plus AgBr. Third one, CH3O minus Na. CH3O Na. Okay. So here you know it's a ionic again, Na plus. It will dissociate to form Na plus CH3O minus. So what is nucleophile over here? CH3O minus, this whole thing. This is a nucleophile. So what will happen? This bromine, between this carbon and bromine, it has partial negative charge and it has partial positive charge. And the CH3O minus, which is a nucleophile, it will come and attack this carbon. And from here, the bromine will left. And you will get CH3O, CH3. So basically, in this, you will get a ether. So this process or this whole synthesis or reaction, क्या बोलते हैं? Williamson ether synthesis. Williamson synthesis, or simply you can write Williamson ether synthesis. Okay, you will learn this, or we will discuss this when we start the alcohol, phenols, and ether. So Williamson ether synthesis is the method of preparation of ether by alkyl halide. Okay, by alkyl halide with the ethanoid group. Okay, your alkanoid group. Okay, when you just read CH3ONA, any white group, so you will get this one, ether. So this is a Williamson synthesis. Now we have already done with the reaction of nucleophilic substitution reaction mechanism. Now factors that affect the nucleophilic substitution reaction, SN1 and SN2. There are three factors we will discuss in this chapter. Nature of substrate, how the nature of substrate affects the SN1 and SN2 reaction. Okay. Second is nature of living group. Nature of living group कैसे depend करता है. And third one is your effect of substrate. Sorry, effect of substrate. These three things we will discuss this in this chapter. First is your nature of substrate. Nature of substrate. Okay, so let's understand the reactivity of nucleophilic substitution reaction. So first हम क्या देखेंगे? SN1 की reactivity. SN1 की reactivity क्या होती है? Rate of reaction is 3 degree, 2 degree, 1 degree. 3 degree, 2 degree, then 1 degree. Because in SN1 reaction, it occurs via the formation of carbocation. Okay, so the rate of nucleophilic substitution reaction will directly proportional to the stability of carbocation. And which carbocation is more stable? Which carbocation is more stable? So tertiary carbocation. Suppose we have this OH group, और आप यहाँ पे OH, because we are just studying the alkyl halide solution. Yeah, CH3, CH3, and this CH. So it's a good living. So you just left and here carbocation का formation हो जाएगा. There will be a formation of carbocation. So this is the tertiary carbocation. Now what happens over here? Happens over here? Uh, this tertiary carbocation, this tertiary one is more stable. It's more stable. So what happens, because this carbocation is more stable and this will have more positive character, this carbon will have the more positive character due to this CH3 group, 3CH3 group. Okay, it will try to stabilize this carbocation. This CH3 group will try to stabilize this carbocation, and this carbocation here, this will have the more positive charge. Okay, so what happens, the nucleophile will come and attack this carbocation, and here the rate will be very fast as compared to the secondary and primary. Okay, secondary and primary. So here the rate of SN1 reaction is directly proportional to the stability of carbocation. So 3-degree carbocation is more stable than 2-degree than 1-degree. So that's why the rate of SN1 reaction is 3-degree, then 2-degree, then 1-degree. Clear, Ali?
Yes, ma'am.
Any doubt?
No, ma'am.
Okay. Next is carbocation is highly, yeah, this one is very important. So the carbocation is highly stabilized by the delocalization of charge due to the resonance. And you know what is resonance? Resonance is basically the delocalization of charge. Okay, it means the movement of pi electrons within a within a ring, within a ring. So that's a resonating structure or resonance. Suppose we have a benzyl group. This is a benzyl group. क्या होता था? So when the, see, what is benzyl group? When the halogen group is attached with first sp3 hybridized carbon, and this sp3 hybridized carbon, when it is attached to the benzene ring, so this is known as benzyl. This is your benzyl group. It's a benzyl group category. So here you can see this is a benzyl group. Halogen atom is first attached to the CH2 group, which is sp3 hybridized. Then it is attached to the benzene ring. So what happens when this X will remove, because it's a good living group, so it will left. यहाँ पे क्या होगा? It will pull all the electron density towards itself. इस carbon के पास क्या आ जाएगा? Positive charge. So you can show it like this. It will acquire partial positive charge over here, and X क्या होगा? Remove it. Now you can see this is a benzene ring and here CH2 plus charge. So what happens over here when you see this type of arrangement? See, this is your pi electron, then sigma, then positive charge. So it will show some resonance. It will show some resonance. So you can see this is a pi electrons. So because pi electrons are movable, they can move within the your ring. So it will move. ये mobile होते हैं, so it will move, and there will be a partial positive. There will be a partial double bond between this carbon and this CH. Partial double bond character between this, and this plus charge will shift over here, right? So plus charge will shift over here, and similarly you can draw the all the resonating structure. So what I want to tell you, the carbocation is highly stabilized. So here the carbocation is being formed. Carbocation यहाँ पे form हुआ when the X is being removed. So here the carbocation is formed. Now this carbocation, due to the delocalization of pi electrons, it will highly stabilize. ये इसे stable बनाता है. When the delocalized, this pi electron will will move within the ring when it delocalizes. So what happens, due to the partial double bond character within this bond is partial double bond. So due to that, the this carbocation is more stabilized. So carbocation is highly stabilized by the delocalization of charge due to the resonance. So that's why when you compare the 3 degree carbocation or the benzyl carbocation, so benzyl is more stable than the 3 degree carbocation. So just keep this in your mind, and it's due to the delocalization of charge. Delocalization of charge. So benzyl, then your 3 degree alkyl halide, then your allylic. Allylic. Now, what does allylic mean? So allylic is basically When the halogen is attached first to the sp3 hybridized carbon, then it is attached to the sp2, just like this. You can see this is a halogen, it is attached to CH2 group, and this is a single bond, so it's a sp3. And this sp3 hybridized carbon is attached to this carbon, so you can see carbon carbon के बीच में क्या है? There is a double bond, so this is sp2. So when you see this type of arrangement, so it's a allylic type of molecule. So order, you can see this. This is a allylic one. So when you remove this halogen group, so because it is more electronegative, it will left the group. So here the carbocation is formed. यहाँ पे carbocation form होगा, plus charge over here. Now this positive one, again this is, you can see this type of arrangement, pi, then sigma, then positive. Okay, so what happens over here? This will shift over here. Okay, and ये bond कहाँ हो जाएगा? यहाँ पे ये positive charge will come over here. So it will again show the resonance. It will again show the resonance. And again the carbocation is, this carbocation is stabilized by the delocalization of pi charge, pi electron. So that's why first क्या होता है? Order or rate of reactivity of SN1 unimolecular nucleophilic substitution reaction is, first होगा benzyl, सबसे ज्यादा किसमें होगा? Benzylic one, then tertiary one, then allylic. Tertiary or allylic both have almost same reactivity, almost. Then after that, secondary one, then primary one. Just keep this in your mind. This is very important. और ये किस टाइप के एग्जाम्स में किस टाइप से पूछे जाएंगे? They will give you to compare. Okay, just arrange these molecules on the basis of the reactivity towards SN1 mechanism, towards SN2 reaction. So that's how you should know SN1 की reactivity क्या होती है? It's SN1. So you know the trick. So benzyl, okay, then your tertiary one. This is a benzyl, tertiary one, then allylic, then 2 degree, then 1 degree. So 3 to 1 आप याद कर सकते हो. 3 to 1 for the SN1 and SN2 के लिए 1 2 3. Primary, then secondary, then tertiary. Clear, Ali?
Yes, ma'am.
Okay, so here, see, the rate of SN1 reaction is directly proportional to the number of benzene ring on the carbocation or CH. So what rate of SN1 mechanism जो होता है reaction is directly proportional to the number of benzene ring. More the number of benzene ring, more will be the rate. More will fast the reaction will be. Right, reactivity will be fast. So suppose we have this. Suppose यहाँ पे एक benzene ring है, and there are another benzene ring too, which is attached to the carbon. So basically, you just remember this rate of SN1 reaction, number of benzene ring पे depend करती है on the carbocation. Okay, so more the benzene ring on the carbocation attached to the carbocation, more will be the rate of reaction towards the SN1. Second point is the number of alkyl. More the alkyl group present on the carbocation, so more will be the reactivity. Now, based on these points, just see this point, these are very, very important. Now, let's do some questions. First question. Okay, just try this, Ali. Which would undergo SN1 reaction faster, A or B? First, try it by yourself. Try to make the carbocation, remove the alkyl halogen group, and to make the carbocation.
B.
Why B? What will be the reason?
Because it is a tertiary carbocation.
Yes, very good. So in SN1 reaction, when you remove this bromine, so this will be the primary carbocation, and this is a tertiary carbocation. We know very well tertiary carbocation is more reactive towards the SN1 reaction. So that's why P. Now this question. Now see this. What will be the order of SN1 for the following? Order of SN1 reaction. So first, let's understand. Let's make the carbocation first. So when you remove this, so here the plus charge, ये carbocation ये होगा. When you remove this will be the carbocation, and this for this will be the carbon. Now compare these three. So in the this C first, let's see C1. So here you can see there are two double bonds, double bonds. So due to this double bond, there will be a more delocalization. There will be इस side से भी क्या होगा delocalization. This will occur over here, and ये charge यहाँ shift हो जाएगा like this. This bond as it is, and this when this pi bond shift over here, and ये क्या हो जाएगा positive charge यहाँ आ जाएगा. Similarly, next step will be again this bond will shift over here, and ये positive charge यहाँ आ जाएगा. Positive charge over here, right? And again, you can just draw the another things. So here, due to the two double charge, two pi bonds, two by pi electrons, there will be a more resonance. There will be a more resonance and more resonating structure होंगे. Okay, but in this case, due to the presence of only one pi electrons, there is less resonance. Okay, so more the resonance, as I told you, the carbocation is highly stabilized by the delocalization of pi electron or charge. More the pi electrons, more will be the delocalization. If more the delocalization, more stable the carbocation is. If it is more stable, तो यहाँ पे reactivity क्या होगी? Fast होगी. Okay, after this there will be this one. Okay, because here again the यहाँ पे pi electrons is present, which will delocalize. Okay, here. So again, due to the delocalization of charge, due to the resonance, the carbocation will be stabilized. So after this C molecule, this one is more reactive towards the SN1 after this one. Okay, this will have this is basically you can see there is no pi electron, so there will be no delocalization over here. So that's the order. सबसे ज्यादा किसमें होगा? C fast सबसे reaction C, after B, after that B, then E. C, then B, then E. That's the order of SN1 reaction. Clear, Ahil? Any doubt in this?
ma'am.
Okay, now do this question. Arrange the following in the increasing order of their reactivity towards SN1 reaction.
ma'am.
10. Okay. Suppose this is your A, B, and C. Now tell me what will be the order for the first one?
Uh, PCA.
A, C, B. Yeah, very good. So 2 bromo, 2 methyl butane. So once you draw this, 2 bromo, 2 methyl. So when this remove, so you will get 1, 2, 3 tertiary carbocation, which is most reactive towards SN1. Then 1 bromopentane. Now, no, after this C1, 2 bromopentane. So 2 bromopentane, basically it will give you secondary one. So this will remove and it will give you secondary. And this third one is your 1 bromo. Your bromo is attached. So it will left and you will get 1 degree. So 3 degree, then 2 degree, then 1 degree. Now similarly for the second one, if it is A, B, and C. Yes, Ali, tell me that.
C, B, then A.
C, B, then A. According to you, it's C, then B, then B. So 1 bromo, 3. Okay, let's check it out. Is it correct or not? So you said C. So first, let's draw the structure of these three. 1 bromo, 3 methyl butane. So 1 bromo. On the first position, let's draw the bromine. So this is a A. B, it's yeah, 2 bromo, 2 methyl butane. This is a methyl. 1, 2, 3, 4. This is it. And C is your this one. This is your C. Now let's check it out. When you remove this, you will get a secondary. You will get a secondary carbocation. When you remove this, you will get a tertiary carbocation. And when you remove the first one, you will get a primary one. So is it correct, Ali? You said C, B, and A. It's wrong, now. C, B, and A. It's wrong. The B will have the most reactivity because in the B you can see this is the tertiary one. So this is a B molecule. B molecule is 2 bromo, 2 methyl butane. So when you remove this bromine, you will get the tertiary type of carbocation, right? So tertiary is most stable. So what will be the order here? B will be the most reactive towards SN1. After B, the secondary one. The secondary one. So C, and after that, primary one, which is A. So that's the order, not this. Okay, Ali?
No.
Okay, corrected. Now, see this question. You have to keep this in your mind. You can see this C6H5 is your phenyl ring, right? Phenyl ring. So once how you will draw the structure, let's check it out. Yeah. So this is your, suppose this is your C and Br, CH2 Br. Okay, and one phenyl CH, and इस कार्बन के पास 2 हाइड्रोजन्स थे, one hydrogen, one hydrogen. That's the structure. Okay, and if you want तो कार्बन के पास आप फिनाइल की जगह पे आप यहाँ पे this structure draw कर सकते हो, the whole benzene ring, this whole benzene. Okay, so you can draw it like this, but I have written pH for that, make it easy. Yeah. Now let's do the second one. Second का draw करो structure. So CH, C, and this bromine, and here the CH3 group is attached. CH3 group is attached, one hydrogen is attached to this carbon and one phenyl. Now, for this one, this is a carbon. Carbon से एक phenyl ring attached है, this phenyl C6H5 and CH3 and C6H means two CH3 over here and one again this C6H5. CH5 means again the phenyl ring, and here the bromine. Here's a bromine group. Now fourth one, draw the fourth one. Yeah, G1. So this carbon, here the bromine group. There are two methyl groups. CH2 twice means two methyl group, but one phenyl. One phenyl group and two methyl group. Okay, now let's check it out. How many phenyl groups हम यहाँ लिखेंगे and CH3 group over here. So in here, in the first compound, only one phenyl group is present. One phenyl group and there is no methyl. But in the second molecule, there is one phenyl, one methyl group. In the third, there are two phenyl, but one molecule, one methyl group. And in the D, you can see here one phenyl but two methyl. Now, how you will check the reactivity? You know very well. See this point. More the benzyl group on the carbocation, more the benzyl group on the carbocation, more will be the reactivity towards SN1. Yeah. So, which one is most reactive? What will be the order? Which one is most reactive? So you can see third one, C, because it has two phenyl ring. Two phenyl ring. So ये benzene क्या करेगा? This phenyl is nothing but it's a benzene over here, right? Two benzyl rings over here. It will increase the reactivity of the C compound. So first the order will be the C. After C, now check it. So here you can see here there are B or D में देखो. Don't be confused in that. So B has only one phenyl ring and one methyl. One methyl. One phenyl and one methyl group. And D has one phenyl but two methyl group. Okay, and one more point was that more the number of carbon or the on the carbocation or more the number of alkyl group. See this point. Yeah, this one. Check this point. Rate of SN1 reaction is directly proportional to the number of this group, okay, on the carbocation. Yeah, more the this group, more will be the reactivity. Second point, the rate of nucleophilic substitution reaction to SN1 basically is directly proportional to the number of alkyl group on the carbocation. Okay, so more the number of alkyl group and more the number of phenyl ring, so more will be the reactivity towards SN. So between the B and D, क्या होगा? D. C के बाद किसकी reactivity ज्यादा होगी? D. After D, it's quite clear. Then B. Then after C. That's the order. That's the order of reactivity towards SN1 reaction. Okay, Ali?
Yes, ma'am.
Okay, now it's a homework. This next question. Write down the question. Predict the reactivity of all isomers of bromobutane towards SN1. Towards SN1. First, you have to draw all the isomers of bromobutane. After that, you have to check. You have to check the reactivity, and you have to write down the order of reactivity.